Hey, so welcome back, and this is another daily LeetCode problem. So today's March 20th, and we got the problem can place flowers, so let's get started. So this is a greedy solution that I'll be providing. So what you're given is a flower bed, and you're trying to place flowers into it. But the catch here is that you can only put a flower, and a flower is represented by like a 1 and a 0. So a flower is equal to 1, and an empty place where you can put the flower is represented by 0. And so essentially, in this scenario, you can put a flower here, and the constraints are you can put a flower if there's no flower on the left or the right of it, which there isn't in this case because these are both 0. And once again, you can put a flower here, but n is what's describing how many flowers that we want to place. And so because we can put a flower just once in both of these examples, this one will return true because we're only trying to place 1. But this one, since we can only place at most 1 and we're trying to put 2, we're going to return false. Okay, so that's essentially the question. There's 2 edge cases here. One of them is, say, if you're trying to put a flower here, you can actually put a flower in this position, even though there's no flower on the left of it or no like empty spot, it's okay, because that you just consider that as a 0. Okay, and so you can just place a flower here. And then the other edge case will be the exact opposite, where you can also put a flower in this position, even though there's none to the right of it. So it's kind of a bit of like exception handling that you'll have to worry about, where you don't want to try to index into the neighboring position after it right here if you're at the end of the array. Okay, and so we'll have to think about those edge cases when we solve this. So to do that, what we're going to do is kind of just iterate through our flower bed. And we'll use enumerate because we care about the indices and we care about the current value. And so we'll grab our flower bed. And so we're going to want to return true if we've been able to decrement this count so that it's less than or equal to 0, right? So if we can put like 7 flowers and we're only trying to put 3, then great. But if we're trying to put 3 flowers and we only put 2, then we'll return false in that case. So what you're going to do is say, okay, given some condition, right, we're going to want to decrement our variable. And so we're also going to want to update in place that we've been able to put a flower here. And that's because as we're going along this array, like say if we did put a flower here, and say this was a 0, then like it's important for us to update this to 1. Otherwise, when we get to this spot, like it's going to see this as a 0 and this as 0, and then it's also going to try to put a spot here and so forth. Like it'll just keep putting 1s because we didn't update the one that we just put a flower at. So you really have to consider that case where, okay, if we were able to place a flower, then we really have to update our flower bed. Oh, and we don't want to call this array, we want to call this flower bed. All right, so one way we can handle this is we have to worry about those edge cases, okay, because this won't work. So it'll work for these kind of base examples just fine, but with all the examples, when you try to submit it, it'll fail. And so we can't do, okay, a kind of a sliding window where you look at the previous flower bed, the current, and the next one. And see if those are all 0. Because if these are all 0, you are kind of able to handle these cases. But when you're on the edges, like on the far left-hand side and the far right-hand side, this won't work and will actually kind of throw an error. Because say if you're at the edge here and you're trying to check this, then you're going to fail. Okay, and so that's essentially it, where, okay, it kind of passes these cases, and you're able to kind of check the flower bed ahead of it and just see if they're all equal to 0. If you try submitting that, you won't be able to pass that case where, okay, but what if you're at the very beginning here, right? So you should be able to place a flower here, and you can. And so to do that, what you can actually do is kind of expand the width of your flower bed. So you can update it. And so this allows us to kind of just add 2 extra spots at the very end, so that, okay, like by adding an extra 0 here, you'll be able to handle this edge case where you can put a 1 here, and this kind of sliding window will work just fine, because now you have that extra spot at the end of it to be checking for it. Same thing in this case. Okay, and so that's one way. So if you run that, it works just fine, and you can actually make it a little bit faster by just saying, okay, if n is less than or equal to 0, then we want to return true right away. So you can kind of put this right in your for loop so you can return early. It's kind of a popular pattern. The other way to handle this is just, okay, you can provide a similar if statement here, which is kind of the main logic behind it. But what we're actually going to do is we'll do this flower bed. If it's equal to 0, I'll just add some brackets because we'll have to have quite a few cases. And I is equal to 0, which handles the edge case on the left-hand side, or the flower bed at I minus 1 is 0. And so this says, okay, if we're at the very beginning, then you don't have to consider if the one previous to it is a 0, because that kind of handles that exception of going out of bounds on the left-hand side, and not returning like true in this case. And then we can do the exact same thing for the right-hand side, right? So if our index is at the length minus 1, or our flower bed at I plus 1 is 0. So let's go ahead and try running that. We got an error. What is it here? Don't need these. Oh, we need an equal sign. Same thing here. And I spelled that wrong. And there too. Flower bed has no length. Length of, if I is equal to the length of our flower bed minus 1. There, I hope that makes a lot more sense. Yeah, so basically this is just so we're handling, okay, if the current position can put a flower, and then we only want to check if the previous position can place a flower if our index isn't a 0. If it is 0, then we just say it's good in that case. And then same thing with the very end. If we're at the very end, then we can just say, okay, we don't have to check the one next to it or the one coming after this position, because we know it'll be fine. Otherwise, we'll actually have to check it and see if it's 0. So yeah, let's go ahead and try submitting that, and success. So yeah, that's today's daily LeetCode problem. It's a greedy solution. It's just O of n time and O of 1 space. You kind of have to update that array in place, which you kind of want to avoid when you're actually programming. You'll be able to discuss the trade-offs if you're doing this for an interview, but often in kind of coding competitions, this is just totally fine to do. And yeah, so you just kind of have to handle these edge cases. You can do it either this way or the other way or your own way. I'm sure there's a lot of different ways you can handle it. So yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks.